Hello, everybody. I had some questions, or I had requests for questions on some of these worksheet questions. So I'm going to go through a few on the front side here, 15 and 17 on the front side, and then I'll go through a few on the back side here. Hopefully this will help you out. Okay, so remember that a lot of these, they'll be adding probabilities because it's or probabilities. So we have a standard deck of cards here that's 52 cards. And for number 15, we want those cards to be both red or both black. Okay, so that means we're pulling two cards at a time, and we're going to have two red cards and two black cards, or two red cards or two black cards. So there are 26 cards in the deck that are red. So our first chance of getting a red card would be 26 out of 52. And since we're doing one card and then the next card, we'll have 25 red cards for our next draw, and we'll have 51 cards left out of the whole deck. That would take care of the red cards. Or we're doing those two black cards. So it'll be the same thing because there's the same amount of black cards as there are red cards in the deck. Okay. And I don't have my fancy calculator with me, so I'm just going to put these into my phone calculator and get a percentage for you. So we got 26 out of 52 times 25 out of 51. And we can just take that times 2 since we're doing it twice, and we get 0.49. So about 49% chance of getting that. And your actual answer, I do have the answer key, is 25 out of 51 for that one. Okay, for 17, we want both twos, so we need to get two twos, or both got to be less than 5. So you kind of have to think through the options in your head, what you have. So there are 4 twos in the deck. It doesn't matter the color. So this will be our chance to get 4 twos. So 4 out of 52 and 3 out of 51. That takes care of our twos, or both less than 5. So that means we could have a 4, a 3, or a 2, and we're just going to disregard the ace as the 1 because it could be the 1 or the 10. Okay, so we got 4 of those, 4 of those, and 4 of those. That would be 12. So we have 12 out of 52. Okay, because that's each 4 from each of those numbers. And then we could have 11 out of 51 because this would be a number less than 5, and that would be our second number less than 5. Okay, and now you might be thinking, well, these are less than 5, which is true. So we have to account for that overlap. So minus pulling 2 twos because we already did that one. So 4 out of 52 times 3 out of 51. Sorry, I'm kind of running out of space. So this is the inclusive part, and really we don't really need to do anything with that because it would cancel out with that one. So you might have been talking through the scenario that, well, if I did both twos, those would be in the both less than 5, which is just this chunk right here. So as a percentage, we got 12 out of 52 times 11 out of 51. Or a decimal, excuse me, 0.049 will go to 8, or that would be about 5%, or yeah, 5.0%. And as a fraction, you get 11 out of 221, which is what you would get if you took 12 times 11, 52 times 51, and you reduce that fraction by 12, I think. Okay, so that's the front side. Let's look at the next side. All right, so the first one we have an urn. Okay, so we have 7 white marbles, 5 blue marbles. 4 marbles are selected without replacement. Find each probability. So we got to do 3 white or 3 blue. Okay, so since we're doing 4 marbles, that means we're going to have 4 fractions for each one of these. So probability of getting 3 white. So our first probability of getting 1 white would be 7 out of 12. Okay, so then getting that next white would be 6 out of 12, and then that next white, oops, not 12, it should be 6 out of 11, goes down by 1, and then it would be 5 out of 10. So this would be one white, second white, third white. Okay, then that means the last one would not be white. Okay, which that means it would be a blue. So that's 5 out of however many we have left, which is 9. So this would be 3 white because that's white, that's white, that's white. Okay, then it says or 3 blue. So or 3 blue would be the same kind of idea. 5 out of 12. So this is our first blue. 4 out of 11, and then 3 out of 10. And our fourth one, we would say that that will be our white one because it's going to be blue, 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 right? So blue, 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 and then a white. So it'd be 7 out of 9. So when we're looking at these, the general idea, we could have a blue, white, white, white. We could have that blue marble that we pick in one of any of these 4 positions. Same thing with this one. So to take into consideration that, you'd have to take these both times 4. Okay, so when we do that, our fraction on the left, so we get 11,880 for our denominator. And on the left here, we would get 4,200 for our numerator. Okay, that's this set of fractions. And then this set of fractions, we would have the same denominator, 11,880. And my numerator, we get 1,680 for this one. If we add 1,680 and 4,200, that's the tops. Okay, so this plus this one, sorry for the messy work here. We get 5,880 over 11,880, which reduces down to 49 over 99. And as a decimal, we get 0.49 repeating, or about 50%. It'd be 49.4, I guess, 49.5%. Okay, so that's little difficult just because you have to remember we could have this 4 different ways because of the way, since we're drawing 4 marbles. Anytime we're drawing more than what you're looking for, so like, you know, we're looking for 3 things, but we're drawing 4, you're going to have to kind of consider it this way. Okay, so similar to that, number 7 here, we have 3 dice that are being tossed. Find each probability. So we need the probability of getting 2 5s. So my first 5 would be 1 6, my second 5 would be 1 6, and then our third one is not going to be a 5, so that would be 5 6. Okay, and then since this is just working with dice, we can just multiply these 3. That kind of takes care of the not getting a 5. And since that not 5, I suppose, can be in any of the 3 positions when we roll, we have to take that times 3, right? Because we could get something that's not a 5 for the first one, something that's not a 5 for the second one, or something that's not a 5 for that third one. So that, when we multiply that out, we get 5 out of 72. And as a percentage, that is 6.9%, or 0.069. Okay, these are going to work kind of the same way. So this one says at least 2 5s. So that means we need 2 5s or 3 5s. Let's get rid of some of this stuff. Okay, we need probability of 2 5s or probability of 3 5s. Well, we just did the 2 5s right there, right? So we got that probability right there. Let's just substitute that in there. So 5 out of 72. And then the other one's actually pretty easy because the probability of getting 3 5s would be 1 6 times 1 6 times 1 6. Okay, which is 6 times 6 times 6 is 216. So this is 1 out of 216. So we add these 2 fractions together. So 5 over 72 plus 1 over 216. And I don't have the fraction for you. I'll get it here in a second. 0.74, or about 7.4%. As a fraction, that's 2 out of 27. Okay, so since we did this one for number 7, that made this one quite a bit easier. All right. This one here shouldn't be too bad. We just want to figure out a probability of getting 1, 5. So that means we can expect to get that first 5 right there as 1 out of 6. And then our other 2 rolls would not be a 5. Okay, so this is not a 5, that's not a 5. And then remember, since we're rolling this, that 1, 6, that 5, or these not 5s could be in different positions. You have to take that times 3. And that will end up getting us 25 over 72. So once you kind of figure out this one, the rest of them just kind of fall in place. Okay. The probabilities that you'll have on your quiz will be easier than this. They won't have to. It'll be probability of rolling 2 dice. What's the probability of getting 1 or 3 or something like that? There's not going to be kind of extra that you have to consider for these. All right. So 13, 15, 17. We'll finish up with those 3. So a clerk chooses 4 CD players at random. From a shipment of 24 CD players, if 15 of them have blue cases, so 15 are blue, and the rest have a red case, so that means we have 9 red cases. What's the probability of choosing 4 players with a blue case or 4 players with a red case? Okay, so are getting 4 players with a blue case, we got 15 that are blue, so 15 out of 24 times, since we're choosing them kind of one after another, there's 14 left to pick from. That'd be 23, 13 out of 22, and 12 out of 21. That would be getting my blue cases. Okay, or 4 with the red case. So, or, here's my red cases. We got 9 out of 24, 8 out of 23, 7 out of 22, and then 6 out of 21. And then you got to do all that fun work to get those fractions, right? So when you do this fraction here, you get 32,760 for your numerator, 255,024 for your denominator. This one you get 3,024 for your numerator and same denominator. And when you add the top, you get 35,784. And you reduce it down. I think you can take out a 504. You get 71 out of 506. And as a decimal, that is 0.14, which is 14%. Okay, and you have to label if these are mutually exclusive or inclusive. This one is a mutually exclusive because choices of picking a blue CD player case or a red case does not affect each other. Okay, so I guess we can do that first on this one. So we got 5 pieces of apple pie, 4 pieces of chocolate cream, and 3 pieces of blueberry. If Janine selects a piece of pie at random for dessert, what's the probability that she selects either apple or chocolate? So apple or chocolate. And it's just picking one piece of pie. So we have 5 pieces that are apple pie, and we have 4 and 3. So add those together, that gets you 12 total. So this would be getting my apple pie, or my chocolate cream is 4. So this would be plus 4 out of 12. So getting one or the other. Okay, and so really those don't affect each other, so these are the same. So these are mutually exclusive as well. So if you add those together, you get 9 out of 12. And reduce that down, we get 3/4 for our answer for that one. So that was not bad. Okay, check out the last one down here. So an airline has one bank of 13 telephones at a reservations office. Okay, so we got 13 total. Of the 13 operators there, 8 of them are for domestic flights, and 5 of them are for international flights. So maybe we can put those off to the side. 8 domestic, 5 are international. 7 of the operators taking domestic reservations and 3 of the operators taking international reservations are female. So 7 of those are female and 3 of those are female. That's going to be some information to help us figure this out. If an operator is chosen at random, what's the probability that the person chosen takes domestic reservations or is male? So we want domestic reservations or male. Okay, so it shouldn't be too bad. So we got to do our domestic reservations. There's 8 of those. Okay, 8 out of 13. That's the domestics. Okay, or male. So 7 and 3, or so 10 of those are female. Right, 7 and 3, 7 and 3, 10 are females, so that means we got 3 males, right? So 3 out of 13 are males. Okay, then we need to consider any overlap we might have counted here. Okay, what about the domestic flight attendants or flight callers, I guess, that are male? Okay. Well, it says 7 of the operators taking domestic reservations are female. So that means 1 of the 8 is a male, which we might have counted for already. So let's take that out. So 1 out of the 13 we already counted for. That would be a domestic phone taker that is male. Okay, so this is the hard part to see. If we add these together, we got 8 out of 13 plus 3 out of 13, that is 11 out of 13, minus 1 out of 13, that puts us at 10 out of 13 for our final answer, okay? So since we had to consider, let's fix that 13 down there. Since we had to consider some overlap here, okay, this is an inclusive event. Inclusive. All right, so this is non-mutually exclusive or inclusive because we had that overlap, okay? When you're working through these questions, especially this one right here, it has a lot of information to read through. It might be beneficial to kind of write some things off to the side or underline some important pieces that you might want to come back to, just like I did, okay? Then also when you're working through these, it kind of helps to highlight what are the 2 things you're looking for, this or this, okay? So that way you can kind of separate them. See how I put parentheses around this one? And I separated it. So I found that probability and then the other one. And I kind of did that here as well. Okay, so apple or chocolate. All right, that might help out with those. So hopefully this video gives you a little bit more insight. I know some of these are a little more difficult, especially like these ones here. But give them a try, work through them, and we will look at some more of these in class. So thank you for watching.